Dear children, welcome to the YouTube channel H2O Chemistry. So in our last video we have learned that what are the features of periods. In this video I'm going to teach you the features of groups. So in our last video we have learned that the horizontal rows from left to right we call them periods. Right, so the horizontal rows from horizontal row from left to right is called periods. So there are 1 2 3 4 5 6 7 periods. Similarly, there is a one more idea. The vertical columns from top to bottom we call groups. So what is the meaning of this group? It is a vertical columns, right? It's a vertical column, we can say from top to bottom, so that is an idea. So you have to remember top to bottom. So this is an idea behind this column, vertical columns. So just look at it. There are how many periods we have? 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18. So there are 18 groups in the modern periodic table. So this is an information you should know. And then next we will see the group names, the first group name, second group name, everything we are going to look at it. So let us see the first group. The first group is called as alkali metals. What is the name of the first group? Alkali metals. So let me write here, it is called alkali metals. So what is the meaning of this alkali? Alkali means it's a basic in nature, right? So which dissolves in water, that's called alkali. So when any metal oxides of alkali, this is lithium oxide, sodium oxide, potassium oxide, these metal when you dissolve in water, it forms soluble hydroxides. That is the meaning, that's the reason it's called alkali metals. The next group is called alkaline earth metal. Alkaline earth metal. So previously the word earth was given to oxygen. So when they are oxides, when their oxides dissolved in water, they become alkaline too. So they dissolve in water. Their hydroxide dissolve in water. So that is the reason we call it as an alkaline earth metal. And then the next will be 3 to 12. So this 3 to 12 is called transition metals. You can see here, I can see alkali metals. The first group is called alkali metal, the second group is called alkaline earth metal, the next group is called transition metals. Transition metals from 3 to 12. And come to the 13th group. 13th group is called boron family. What family it is? Boron family. You could see the first member of the group is boron, so it's called boron family. The next group, 14th group, is the first member is carbon, so it is called carbon family. The next one, 15, the first member is nitrogen, so the nitrogen, it is called nitrogen family. So let me say one more time, the 13th group is called boron family, right? The next group, carbon, is called carbon family. The next group is called, the first element is nitrogen, so it is called nitrogen family. The next group is called oxygen family. Oxygen, the first member is oxygen, so it is called oxygen family. The oxygen family otherwise called, the oxygen family otherwise called chalcogens. So this word is important. So the oxygen family is otherwise called chalcogens. Okay, let me go with the idea, that is chalcogens. We will see what is the meaning of this. So it is called chalcogens. Group 16. Group 16 is called oxygen family, otherwise called chalcogens. If I cut this, the word chalco means ore, gen means generators. So they are ore formers group or ore generators group. That's the reason it's called chalcogens. The next one, 17th group, you could see the 17th group. The 17th group elements are called halogens. Halogens. Okay, let us see the next word, that is a group number 17. Group number 17 is called halogen. Again, halo means salt, gen means generators. So they are salt generators or salt formers. Got it? The next one, group 18, I could see, is otherwise called noble gases, right? So the group 18 is called noble gases or inert gases or rare gases. So these are the ideas. Noble and rare means they are occurring in a very rare manner. That's the reason they are called noble or inert gases. And inert, noble or rare gases. Inert means they are inactive chemically inactive with other substance. That's the reason they are called inert gases. So the 18th group elements are called as noble gases or inert gases. Understand? So you could see that chalcogens here, the oxygen family, F, this halogens. Okay, this is the idea you should understand. So let me quickly review the names. Recall the names: alkali metals, alkaline earth metals, transition metals, boron family, carbon family, nitrogen family, oxygen family, halogens, chalcogens. Oxygen is otherwise called chalcogens, right? Now, the next point, you could see here in the transition metals, right? In the transition metal, in the third group, there is something different color is given. You could see here. This is actually given in the bottom of the periodic table. You could see this clearly, bottom of the periodic table. So from 57 atomic number to 71 is given here. So that means this is belong to this group, right? So this will occupy this. So I can say they are transition metals, but this is called as inner transition metal. Look at the first element, lanthanum. So it starts with lanthanum. That's the reason it is called lanthanides. Otherwise we call lanthanoids. Both are same. So the first element of this is lanthanum. So this is why it's called lanthanides or lanthanoids. Similarly, come to the seventh period. In this third group, there is a one more from actinum to the lawrencium it is given. So from 89 atomic number to 103. So this is called as actinides or actinoids. So these are the two block elements is given separately at the bottom. So this block is called as inner transition elements because they present inside. That's the reason they are called inner transition elements. Inner transition elements. Now next, come to the next one. So I want to clarify one more information, that is what about group 1 elements? So we will look at that group 1 elements, lithium, sodium, potassium. So we will go with this. So initially we will go with the lithium and sodium and potassium. What I want is electronic configuration. Okay, what is the atomic number of lithium? That is 3. Sodium is 11. Potassium is 19. Okay, let me write the electronic configuration. For lithium, it is 3 electrons, so 2, 1. For sodium, it is 11 electrons, so 2, 8, 1. And for the potassium is 19 electrons, so 2, 8, 8, 1. 2, 8, 8, 1. So look at the last shell, valence shell electrons. All these elements have 1 electron in the last shell. Am I right? So that is the idea, my dear children. So the valency of this group is 1. So when they react chemically, they lose these outermost shell electrons easily, right? So the lithium will lose electron to form lithium 1 plus, right? So it will occur 1 plus. Similarly, sodium will lose the outermost 1 electron and form sodium 1 plus plus electron. So what you have identified here, very simple, they have a similar valency. Am I right? They have a similar valency because they have a same number of electron in the last shell. Same number of electron in the last shell. This is very important, my dear children. Got it? So all the elements present in the group 1 has the valency of 1. Got it? Similarly, group number 2 has the valency of 2. 13 group also has a valency of 3. So this idea we have already learnt in the 9th standard. So just a recall, remember. What about this last group? So let us have one again: helium, neon, argon. So let us have the 3 electronic configuration: helium, neon, argon. So let us have a small recall. So K shell, M shell, N shell, and N shell. So atomic number of helium is 2, neon is 10, argon is 18. So in the K shell 2, in the neon case, K shell is 2, L shell is 8. In the argon case, K shell is 2, L shell is 8, M shell also 8. So the remaining cells are empty. Now look at here, the last shell of neon and argon alone is 8, whereas the helium is 2. So in the last group alone, we will not find same number of valence electrons. So just we have seen in the first group we have a single electrons in the last shell. That's why they are placed in the first group. Whereas in the 18th group, if you look at it, the helium alone is an exception. It has only 2 electrons, whereas the neon and argon has 8 electrons in the valence shell. Other elements too have 8 electrons in the valence shell. So this group alone is an exception in this case. So generally the group number is nothing but a valency for metals. So but only one case here, the valency of this noble gases is 0, because we used to write 8 minus 8 is equal to 0. So that's why it's otherwise called 0 group. Otherwise called 0 group. Am I right? 0 group. But what actually happens is the valency of this particular group is 0. Am I right? Is 0. But they do not have a same number of valence electrons. You could see the valence electrons are different in the 18th group alone, but remaining groups all are same. If you look at this 17th group, the valence electron is 7, right? So the valency is 1. So this we have learned already in your 9th standard. Now the next one idea is, so we know that when they have a same number of valence electrons, their chemical property also same. Look at the first period: lithium, sodium, and potassium. So let me write some reactions of lithium. So lithium, when it reacts with oxygen, it forms what? Li2O. So let me balance this. We have a 2 and 2, and we have only one oxygen. So let me write 2 here. So there are 4 lithiums and 2 oxygens. So let me do a crisscross method, whether this formula is correct or not. Lithium valency is 1, oxygen valency is 2. When you crisscross is 2 and comes here, 2 goes here, 1 goes here. So lithium 2, oxygen 1. So this formula is right. What about sodium? Sodium, when reacts with oxygen, it forms Na2O, right? So here again 2 and 2. Similarly, potassium, when reacts with oxygen, it forms K2O. So what you understood? The chemical property depends upon the valence electrons. So very simple, the valence electron decides the chemical property. Am I right? So the group 1 elements behaves in a similar manner. Similarly, group 2 elements will behave in a similar manner. But group 1 and group 2 will have a different chemical property because they have a different number of valence electron in the last shell. That's an idea, my dear children. So what is the conclusion? So if depending upon the number of valence electrons, they have a different chemical property. So each group will have a different chemical property, but the elements present in each group, the element present in the particular group will have a similar chemical property. So that is an idea. So if any element belongs to group number 1, So that is having the property of group number 1 other elements of group number 1. So what is the property of lithium? By knowing the property of lithium, we can assume the other properties of sodium, potassium, rubidium. So with the electronic configuration, we can find out the chemical property. So why these elements are grouped together? Because their valency is same, their chemical property is same. That is the reason they are grouped. Got it? Next one. The physical property of an element in a group, such as melting point, boiling point, generally vary, right? From coming down the group, the melting point increases. So that is an idea, my dear children. The boiling point increases. That is an idea, my dear children. So gradually it's vary from lithium to sodium and then potassium, like that. It's vary. Come to the last one. See here, the last group electrons, the last group, 18th group elements, as I said, noble gases, they have a 2, 8, 8 electrons. So it actually has a stable electronic configuration, doublet and octet rule. You might have learned in 9th standard. So doublet means 2 electron the last shell. It is applicable for helium. Octet means 8 electron the last shell. It's applicable for other noble gases, neon, argon, krypton and all. So they have a stable electronic configuration. Stable electronic configuration. So they are chemically inert. So I can say these group are chemically inert. So they are unreactive. So last group, the valency is 0. That means they are chemically unreactive. I hope, my dear children, this video is very helpful in learning the features of groups. Thanks for watching. If you like this video, you can share and like. Subscribe for more videos. The chemistry concepts made easy here. Click the bell button to get the notification instantly. Thank you.